have any questions or any doubts in last session? Can anyone please remind me what we did in the last session? What was the last topic which we discussed in the last class? Yeah, okay. So in last class, we understood about the keypad interfacing, where we used one IC 4511 7 segment display common cathode, one Atmega 16 IC, and 10 buttons. And we assign the roles to those buttons. Like if we press the first button, it must print 0. The next button must print 1. And in the same way, we have to create a keypad, it's numpad, to print numbers 0 to 9 using 10 different buttons. So let's start with the new topic, which is called motor interfacing. Till now, we have covered three different topics in AVR programming. The first one was LED interface. Second one was 7 segment interface. And I gave you the assignment to try with 14 segment and 16 segment displays and try printing M and N in a loop. After that, we understood about sensor interfacing or button interface, where we use one sensor, one LED, then two sensors, two LED. And in this program, which we can see here currently, is also related to your button interface, where we used a keypad kind of system using 7 segment and buttons. So in this program, in this project, in this circuit, we included two different topics. Now we are going to start with motor interface. So let's create a new design sheet for that. And I'm picking at Mega 16. And then we need a motor. So let's use one motor. And also we need a button. Okay, let's not use the button for now. Let's only use the motor. So here we have at Mega 16, and then let's connect a motor with it. We have two terminals of the motor, the plus one and the minus one. So the topmost is plus and the bottom one is negative. We cannot connect the motor directly to the controller, as I said in the last session as well, when we were doing, not exactly in the last session, I mean, in the last few sessions, I told you about motor interface. That motor needs the operating voltage of 12 volt, and this controller is going to provide only 5 volt of the source. So basically, it wouldn't be possible for the motor to give 100% efficient output using this 5 volt. That is why we need one IC in between the motor and controller. Let's understand the case if suppose we are using a motor of 5 volts only, and your controller is also providing the same 5 volt. That time, according to our logic, yes, we can use the motor with at Mega 16 directly. But still, I do not recommend those things. The reason being, it's not only about voltage, it's about current as well. Because when we connect any motor with at Mega 16, at Mega 16 provide the 5 volt logic from each pin, and the current rating is just around 20 milliampere per pin. If your voltage is 5 volt, then current rating is 20 milliampere, and if the voltage is 3.3 volt, then the current rating is around 50 milliampere. But if we talk about a motor, it needs around 1 ampere to start. And it's not only about DC motor, even if we use AC motors, the start current is high. So to manage the start current, we use star delta connections and other devices as well. But here we cannot use star delta connection. What we can do, suppose if we have a motor and it needs 1 ampere, and your controller spins are providing only 20 milliampere or 50 milliampere, then it wouldn't be possible for us to draw the motor at 100% efficient output. That is why I do not recommend to connect the motors directly with any controller. We must use one driver IC. So I guess, already discussed in the simulation sessions about the driver IC L293D. So let's pick one IC L293D. L293D is motor driver IC, which behaves like a switch in between the motor and controller. It has total 16 pins, 8 on the left side and 8 on the right sides. So motor 1 is completely connected on the left side, whereas the motor 2 is completely connected on the right side. And we already know about, if we want to give the logic, we can give the logic to input 1, and accordingly it will give the output to the pin output 1, which we can connect to the positive of the motor. And then PC1 I'm connecting with input 2, and output 2 I'm connecting with the second terminal of your motor. That means if we give the logic of 5 volt from PC0 and the logic of 0 volt from PC1, which are in terms of binary 1 0, then here we get same logic 1 and 0, but the voltage is 12 volt. This IC is not actually boosting the voltage. It's working as a switch in between the power source of 12 volt and the motor. So what exactly we have to do? We have to take a power source of 12 volt here, which is called external power supply. For now, we are not giving any power to this at Mega 16 IC because it already has it in the software by default. But when we use this same scenario in hardware, that time we need this 12 volt of supply to the controller. Sorry, 12 volt of supply to the L293D and 5 volt of supply to your controller, because your controller's operating voltage is 4.5 to 5.5 volt. So that time generally we create the power supply circuit which converts 220 volt into 5 volt of DC. But when we have to use the motor, we won't be converting that 220 volt of AC to 5 volt DC directly. First we will convert that to 12 volt DC, and then further it will convert to 5 volt DC. So whenever we have a motor, we make the supply 220 to 12 to 5 volt DC. So wherever it is required to provide 12 volt, we connect it directly with the 12 volt source, and wherever it is required to connect with 5 volt, we provide the 5 volt supply from the source power supply. Now this IC also needs the 5 volt to operate. So let's connect 5 volt to this VSS, and enable one I'm connecting with same 5 volt source, and let's connect the ground to this terminal. So another ground is not required for now, as we are using only one motor. In the same way, another enable 2 is also not required because we do not have to enable the right side of the motor, which is concerned to second motor. So for now, the circuit is almost completed. We have to start the programming. Let's go to the AVR Studio software. And there we are just going to write DDR, as we are using port C. So DDRC equals to 0B, or 0X also we can write FF. It is 0B 11 11 11 11. That means we are using all the pins as output. And just after this, we have to, if suppose we want to turn on the motor, then we have connected the motor positive terminal with port C0 and negative terminal with port C1. So suppose if you want to rotate your motor in clockwise direction, we have to give the logic 1 to PC0 and logic 0 to PC1. So that's what we have to write in the code. Port C equals to 0B 0 0 0 0 0 0. So starting 6 pins are 0 because those pins are not output and not even input. So we have to keep it 0. And then after this, if we want to rotate the motor in clockwise direction, we have to simply write 0 1. Now let's write a delay of 2 milliseconds, sorry, 2 seconds. So underscore delay underscore ms and 2 seconds. And suppose if you wanted to rotate in anti-clockwise direction just after 2 seconds, we have to write the code 0b 00000010. So 10 means that the motor is now rotating in anti-clockwise direction. And in the same way, I'm again giving the delay of 2 seconds after this. And finally, if you want to stop the motor, then 0b 00000000. So generally the code 01 is for clockwise and code 10 is for anti-clockwise and code 00 is to stop your motor. So now we have mentioned three different codes back to back after delay of 2 seconds each. Now we have to just compile and check how it's working. Also, as we have included the delay function here, we need to write the header file as well. So it must be hash include util slash delay dot h. And then this part is in a while loop. That means it's going to repeat the process for infinity period of time. So util slash delay dot h is not available because we have mentioned it util dot delay and it must be util slash delay. Okay, fine, it's done. Now let's go to the Proteus one where we build the circuit. And in that circuit, simply let's double click on your controller, browse the file, which is already stored in this folder batch 10 p.m. 21st June, and the code for the day is P8. And let's now put the hex file to the machine, and we can see the motor is rotating in clockwise directions. In next 2 seconds, it's rotating in anti-clockwise direction, and then for next 2 seconds stopped. And after that, the whole process is repeating. So on 2 seconds, off 2 seconds, stop 2 seconds. This is the flow of your program in while loop. So if anyone has any doubts, can ask. Otherwise, we will do something smart in this. Okay, fine. So now let's include the sensor interface in the same program. So I'm going to save it. It's P8. And then let's save as P9. So P8 was the last code, and now I'm going to edit the same code because with same connections, we have to connect a button. If we turn on the button, then only motor should work. Otherwise, it should not work. If you want to take two different buttons, we can do that as well. One for clockwise, another one for anti-clockwise. In that way, I'll suggest you that if you want to use two buttons at the same time, then use three buttons, one to clockwise, one to anti-clockwise, and one to stop the whole process. So let's use button, and wherever we use button, we need registers as well. So let's put the button here. Now here we have two terminals for button, and we already know the one must be connected with power, another one must be connected with port A0 pin number 40. And then let's connect the register and let's keep it ground. You can also connect the ground of your L29 3D and register common, but that's okay if you don't in the simulation, but in real time it is must to short both the grounds. Now we have to include the coding part that we are using one button which is connected at port A0, and when the button is on, let's rotate the motor in clockwise direction, and the button when the button is off, the motor should not work. So let's go to the code and create a new project. Meanwhile, if anyone has any doubts, can ask me. Okay, so this time we don't need this delay function because now we are not asking the motor to rotate clockwise and to clockwise back to back. Because now we have a control through buttons. So we will be like turning on the button to keep your motor clockwise and turning off the button or another button to anti-clockwise. For now, for this program, I'm only considering one direction, which is clockwise. Another one is the stop process. So just after int min, let's start writing the DDR, and DDRC equals to 0B. As we have connected the motor to this port, let's define this whole port as output. So 1 1 1 1 1 1 and 1 1. And after this, DDRA equals to 0B. We connected the button at this port, so 0 0 0 0 0 0 0 1. Because not 0 1, it must be 0 0. So all the pins of port C are declared as output, and port A are declared as input. Now let's go to the while loop and try to run the code. But before we start comparing the condition inside the if loop, first we also need to read the data. And to read the data, masking is also required here. So let's do the masking part, and how I'm doing it. Int x equals to pin A 0B 00000001. So total we have 8 pins in the port, where we have only connected one button at port A0, but we define the whole port as input. And here when we have int x equals to pin A and this code, then obviously when we have only one button, we have to keep one pin high. Now let's start comparing the conditions. If x equals to 0b 000001, that means the first button is on. Let's start the bracket and write the code for port C, where we have the motor 0b 00000001, the clockwise direction. And after this, let's close the loop if and start a new loop else if, and x equals to 0b 00000010. And then we can, one sec, I need to check, are the digits completed? 000001. Yeah, that was the problem here, because we have 8 pins in the code, so the code length, binary code length, must be 8-bit only. Now the second condition is when we keep the button off, so it must not be 1 0, it should be 0 0. Or otherwise you can skip this whole part, else is understood that the first condition is not working. So here let's write port C equals to 0B 00000000. So let's turn off the LED motor, I mean. Okay, so here let's upload the code P9. And let's put the hex file to this controller. So now we are able to see, if we turn on the button, the motor is working in clockwise direction, and if we do not press the button, the motor direction is stopped. I mean, it's not working. And now if you want the second button for anti-clockwise operation, we can add that into the code. This time we need to declare two different inputs. Until now we have used only one input. So let's define one, let's pick one more button and connect it to port A1 only. So it's button, and let's connect it to port A1, and then this pin must be power. So we already have the power. I just connected there. We need a register which must connect in parallel. So let's connect it to here, and let's connect it to here. Now let's write the code. This time we have two buttons. So simply it must be x equals to pin A and 0B 00000011. That means we are using two different buttons this time. And if the first button is on, the direction of motor is clockwise. And when the second button is on, so this time we need to write the condition here with else. So it must be else if and x equals to 0b 00000010. That means if you want
सर कुछ दिख नहीं रहा सर, सिर्फ एप्लीकेशन कोड यही दिख रहा है, उसके अलावा इधर साइड का नहीं दिख रहा सर, लेफ्ट साइड।
आपके उसमें इशू हो रहा होगा बिकॉज हम तो बहुत देर से कर रहे हैं सेशन। व्हाट अबाउट यू
अभी
आशुतोष?
दिख रहा था, अब नहीं दिख रहा सर।
Sir, everything
That,
is visible, sir.
yeah, that's what I'm saying. See, actually, this is because of your internet connection, you are facing that issue. Try to end the meet and rejoin it. I mean, leave the meet and rejoin the session. Yeah. Okay, so this time we are turning on the second button, and at that time we need the motor to work in anti-clockwise direction. So 000000 and 10. So now the motor is anti-clockwise direction, and let's start writing the last code, which is else. And in else, it's understood that the first button is not on. The second button is also not on. So we have to keep the motor to stop position. So port C equals to 0B 00000000. We can also include one more case here. Let's suppose if both the buttons are on together. So if we have a condition, obviously we need to write the condition in the if loop. So if is also already considered. So next one must be else if. So in else if, let's write x equals to 0b and 00000011. That means both the buttons are on. And now accordingly, I will write the code to keep both to stop the motor. Port C equals to 0b 00000000. Although we can define this in else loop only, because wherever we use else, that means all the above conditions are not satisfied. So what I mean to say, that third code is not required, where I simply said if both buttons are on, then stop the motor. So if the last case, if you see in this and the second last case, if you see, they are almost equal. So now it's done. Let's build the code. We come to Proteus, stop it and start it. So the first button is to rotate your motor in clockwise direction, and the second button is to rotate your motor in anti-clockwise direction. This way we can do a lot of motors and lot of L293D ICs. Okay, guys. So do you have any questions or problems in this question? How to rotate in clockwise, anti-clockwise? How to uh, use two buttons? Where to connect? I told you everything about this. If you do not have any doubts, I'm in favor to end the class for the day. Actually, I'm not feeling so much well today. So I just did the class because I don't want to skip it. You also have your exams in sorry, you also have your college semester starting in few days. So we have to try to wind it up as soon as possible. But yeah, for the day it's enough. I'm not considering any new topic after this. If you have any questions or doubts, you can ask. Otherwise, I'm going to end the meet.
No doubt, sir.
Okay, fine. So guys, see you tomorrow. What exactly you have to do with the assignment? You have to use two different motors and two different buttons. The first button is to rotate your first motor in clockwise direction, whereas the second motor in clockwise direction. And if we on the second button, the first motor must be anti-clockwise and the second must be clockwise. And if we keep both the buttons on, that time the motor must be off. And if we keep both the buttons off, the motor must be off again. So this circuit diagram, you have to try along with the programming, and then we will see the next topic in next lecture, that is tomorrow. Okay, guys. So I'm going to end the meet. See you in the next class. Bye bye. Take care. Good night.
Okay.